Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. Okay, so for today's class, we are going to proceed with the same topic, which is progression, but under the subtopic of some of the first terms of arithmetic progression. So let's begin. Okay, our objective for today's lesson is, at the end of the class, you should be able to derive the formula of some of the first terms of the arithmetic progression, and you should be able to apply the formula for various situations, and then you should also be able to solve problems involving arithmetic progression. So let's explore. So from this inquiry tree activity, okay, our aim is to derive the formula of some of the first n terms, which we call as Sn of the arithmetic progression. Okay, so let's observe the table below. So as we can see, when we have S2, which is sum of the first two terms, okay, the diagram here, we see that we have T1, in which the width is 1 unit and the length is A. And then the second term, the width is the same as the first term, which is 1 unit, but the length is A plus D. Okay, because this is A. Okay, that is A. So we have the second term, the length is A plus D, and then the first term, the length is A, while their width is the same, which is 1 unit. So before, we have learned that the formula for the n term is A plus n minus 1 times D. So when we talk about n equals to 1, okay, when we talk about n equals to 1, so when n equals to 1, so of course, T1 should be equals to A plus 1 minus 1 times D. So we will have A. Okay, so the same goes to T2. So T2 is A plus 2 minus 1 times D. So we have A plus D. So basically, this is our first diagram. Okay, and then we want to the third column, we are looking for the area of rectangle. Okay, the area of rectangle. So as you can see, before in diagram 1, we have only this rectangle, and then at the third column we have this one, which is the origin diagram, and then we have the other one, okay, the addition one. Why? Because we want to find the area of rectangle. So which rectangle? This one. So the addition of the first and second term is to produce a rectangle. Okay, is to produce a rectangle. So basically, the area of rectangle is actually 2 times the first term plus the second term. Of course, because initially we have only this one and this one, the first term and the second term. But in order for us to produce a rectangle, so we need another addition of first term and second term. So we have two. Actually, we have twice, the first term and the second term. So that is why here, area of the rectangle is 2 times the first term and the second term. So by using the n term formula, so we said that, oh, the first term is A, and then the second term is A plus 2 minus 1 times D. And then since we said that the square produced twice the first diagram, so times 2 here. So again, what is Sn? Okay, Sn is, okay, what is Sn? No, I mean, what is S2? Okay, what is S2? S2 is actually the sum of the first two terms. Or I can also say that S2 is actually T1 plus T2. Okay, T1 plus T2. But from this rectangle, we can see that, oh, T1 plus T2, we just need this part. Only this part. Okay, we need this part only. T1 plus T2. So, of course, since we want to find this area only, so in which the area is half of the area of the rectangle, so we need to divide it by 2. Okay, can you follow? Why must we divide it by 2? Because T1 plus T2 is half of the area of the whole rectangle. Half. That is why we divide it by 2. Okay, this is for S2 cases. And then we look at S3 cases. S3 cases, but S3 case. Okay, so S3 case, the same thing. Okay, the same thing. Oh, this is the origin one. Okay, the original one. Okay, this one. So, before T2, A plus D, the length, but T3, it must be A plus 2D. Okay, A plus 2D. So, we have our first term, second term, and the third term. Okay, and then we want to form a rectangle. So, when we form a rectangle, so as you can see, so this is the origin one. And then we add another first, second, and third term. So, we arrange it accordingly, and we will find our rectangle. So, again, this T2 plus T2 is actually, okay, T2 plus T2 is actually T1 plus T3, right? So, we can say, oh, we have 3 times T1 plus T3. So, this one. Okay, 3 times T1 plus T3. Again, what is S3? So, S3 is equals to the sum of the first 3 terms. So, T1 plus T2 plus T3. So, where is our area? Our area is here. Okay. This is our area for S3. So again, we said that, oh, the area for T1 plus T2 plus T3 is half of the area of rectangle. So since we talk about half, equal size, that is why we need to divide it by 2. Okay, that is why we need to divide it by 2. Okay. So, since T1 is A and T3 is A plus 2D, so 3 over 2 in bracket A plus 2D. That is S3. Okay, can you follow? I hope you can follow, okay? Okay, so this part is basically is the same thing as before. I have explained it to you. Also for this part, for S3. And how about S4? Okay, S4, it means that, oh, we have this one. We have this one. This one. And this one. So this is A. Okay, this is A plus D, the second term. Okay, and this is T3, the third term, and this is our fourth term. a plus 3d. Again, when we talk about wanting to have to produce what we call it as apa namanya tu, rectangle kan. So rectangle, so basically we are talking about this one. Okay, so the biggest one must be add up to the smallest one. So this one, this is A, and then this one add up with the second one. Okay, so we have this one. This one add up to the same. Okay, and this one add up to the biggest one. So we have this square. Okay, so since we are talking about S4, so S4 is actually T1 plus T4, because this is T1, this is T4. And why does 4 here? Because this T1 plus T4 is equals to T2 plus T2 is equals to T3 plus T3 plus T apa ni? T2, oh silap, this is T3. T3 plus T2, and then this one, the same goes to T1 plus T4. So we have 4 equal size for T1 plus T4. So this is why 4 here. And then again, when we talk about S4, S4 is actually T1 plus T2 plus T3 plus T4. The sum of the first 4 terms. So from first term, add up to the fourth term. Okay, so where is the area? So where is the area that we are talking about? So this one. Okay, so as we can see, the area for S4, or the area for the addition from the first term to the fourth term, is half of the area for the rectangle. So that is why when we talk about half, this is where divided by 2 comes in. Okay, so we can see that S4 is actually 4 times 2a plus 3d over 2. Okay, so let me write it down here. Okay, so before we have S3, in which this is 3, this is 2a plus 2d over 2, and then we have our S2, 2a plus 2 minus 1d over 2, and this is let me rewrite it as 2a plus 3 minus 1d. Okay, so from here you can see a pattern. When Sn, in which when n equals to 4, this is 4. However, this is 2a. The 2a maintained. And this is 4 minus 1. Okay, we talk about Sn here. So we said that, this is n. This is n minus 1. Okay, when n equals to 3, this is 3. And then this is 3 minus 1, in which it relates to n minus 1, because n minus 1, our n is 3. The same goes to when n equals to 2. So this is n, this is n minus 1. Okay, so we can see the pattern. We can say that, oh, if Sn, so we can say that, oh, it must be n and then 2a, because 2a is fixed. As you can see, this is fixed, this is fixed, this is fixed. The same goes to d. D is fixed. So 2a plus n minus 1 times d over 2. Right? So for any value, the sum of terms of n terms is n over 2 n times 2a plus the whole thing n minus 1 times d divided by 2. So this is when we have our equation our equation for sum of terms, for sum of the first n terms for arithmetic progression will be Sn equals to n over 2 multiplied by the whole 2a plus the multiplication of common difference d with n minus 1. So this is our formula for sum of the first n terms in arithmetic progression. So that is how the formula comes from. We relate it with the area of rectangle. Okay, so you need to understand how the derivation comes from. Okay, next. So sum of the first terms in arithmetic progression, which we call as Sn. What it's all about. So from the first inquiry, okay, we found that the sum of the first n terms Sn is derived as n over 2 times 2a plus n minus 1 times d. Okay, this is the formula. Such that a is the first term. Okay, a is the first term and d is the common difference. Okay, next. Since the n term, which is Tn equals to a plus n minus 1 times d, is also the last term, L, okay, hence the sum of the n term Sn can be expressed as Sn is equals to n over 2, of course, y divided by 2 because the area is half, okay, times the addition of the first term and the last term. This is the first term, this is the last term. Or we can say that Sn is equals to n over 2 multiplied with the addition of the first and the last term. Okay. And we can also find the n term by using the sum of terms. Okay, let's say, how can we find the value of the 10th term by using the sum of terms? By using the sum of the first 10 terms. Okay, so let's say we have T1, T2, T3, T4, T5, blah blah blah, T9, T10. So we have 10 terms here. Okay, when we talk about Sn, we are talking about the addition from the first term until the 10th term. So this is what we call S10. Okay, how can you find this part, only this part? How can you find the 10th term? Of course, S10 must be deducted with S9, right? Okay, in order for us to find the 10th term, we need to deduct S9 from S10. So what is S9? The addition from the first term to the 9th term. What is S10? The addition from the first term to the 10th term. So T10 is actually, the 10th term is actually the sum of the 10th term minus sum of the 9th term. Okay, you need to multiply before the 10th term, the sum of the all the terms before the n terms. Okay, can you follow? So that is why we have this part. Tn is equals to Sn minus Sn minus 1. Okay. Next. Okay, this is our formula. So this is the formula in which we don't give the last term. So we need to find we need to use this one, and then this is when in the question you are given the first term and the last term, so it is easier to find the sum of the first terms by using this one. So we have two formula actually for the sum of the first terms in arithmetic progression. Okay, so let's look at example 1. For each of the following arithmetic progressions, calculate the sum of the n terms, okay, that is indicated in the bracket. Brackets. Okay, here E. Okay, so the first series is 3, 6 and a half, 10. Okay, so we need to find sum of the first 10 terms. Okay, so from here we can see that the first term is 3 and the second term is 3.5. So n equals to 10 is the 10 terms. Okay, the 10 terms is n equals to 10 doesn't represent this one. This one is the third term. But n equals to 10 define that we have 10 terms. The sum of the 10 terms. The sum of the 10 terms. Okay. So since we are talking about the sum of the 10 terms, we are talking about the sum of the first 10 terms in that arithmetic progression. So we need to use this formula. Sn is equal to n over 2 times 2a plus n minus 1 d. So by using the formula, you substitute all the information given. So we will have the first 10 terms in that arithmetic progression series will be 187.50. Okay, simple. Okay, simple. Okay, why don't we find T3 minus T2? It's okay, we don't have to find it because the question has stated that it is arithmetic progression. Okay, let's look at B. This is our series 5.8, 4.9, 4.10. 4.0. So find the sum of the first 18 terms. Okay, the first 18 terms. So from the series, we know that our A is 5.8, our D is negative 0.9. Okay, as you can see here, I use this T3 minus T2, but this one I use T2 minus T1. So the same. Okay, the same. So n equals to 18. Why 18? Because we said that we want to find the sum of the first 18 terms. So by using the sum of the first terms in arithmetic progression, this equation, this formula, so you substitute all the values. So we have S18 is negative 33.30. Okay, so we can conclude that the sum of the first terms in arithmetic does not only contain positive value, it can also be a negative value. Okay, this is the simple one. Okay, let's look at example 2. Find the sum of the following arithmetic progressions. So A, we have this is T1, T2, T3, T4, blah blah blah, and this is our n term, or we call it as last term. Okay, so since we are talking about sum of the progression, so from the question we know that A is negative 12, D is 3, and our last term is 30. So what is n? Okay, what is n first? Okay, so as you can see, negative 9 is T2 here, minus T1. Okay, so we know that, our last term is 30. So that means the n term, or T of n, is equals to 30. So what is the formula for Tn? Tn is a plus n minus 1 d. Okay, so since this is Tn, this is Tn, we can say that, oh, this would be equal. So by using all the values for a and d, okay, you substitute the values, make it equals to 30. So we have n is equals to 15. So that means 30 is the 15th term. Okay, the 15th term. 50th term. Okay, so since we know that our n is 15, of course, when the question asks for some of the first terms for that arithmetic progression, so you know that you need to find S15. So by using the formula A plus L, because we know our last term, which is 30, our first term is negative 12. Okay, just apply. So we have our S15, or our sum of the first 15 terms in that arithmetic progression would be 135. Okay, so let's look at B. So our B, this is our first term, second term, third term, and then this is our last term, or we say that as T of n. Okay, so from the question, we know that, oh, our first term is Q, our common difference is 5Q, and our last term is 41Q. Find what is n. Okay, what is n? So first of all, we know that when L equals to 41Q, it means that T of n is also 41Q. By applying the formula for the n term of arithmetic progression, okay, we can say that, oh, Q plus n minus 1 times 5Q is actually 41Q. So you solve this equation, you have this n is equals to 9. So that means that 41Q is the 9th term of the series. Okay, since we know that our n is 9, so we can find the sum of the first 9 terms for that series. So substitute all the values. We have our S9 is 189Q. Simple, right? Okay, if you have the first term and the last term, it is easier to find the sum of terms by using this formula. Okay, but if someone asks me, can we use the other formula? Of course, you can. The answer will be the same. Okay, let's explore. Okay, discuss S8 minus S5 is equals to T6 plus T7 plus T8. Okay, let's look here. We have this term until the 8th term. Okay, when we talk about S8, S8 is the addition from the first term until the 8th term, right? When we talk about S5, S5 is the addition from the first term until the 5th term. So, when we say that S8 minus S5, what is left? Of course, the addition of the 6th term until the 7th term. Okay, until the 7th term. Okay, so we have proven that S8 minus S5 is actually T6 plus T7 plus T8. Okay, if I ask you, what is the addition from the second term until the 7th term? Okay, what is the sum from the second term to the 7th term? So we have T1, T2, T3, T4, T5, T6, T7, T8. So I want from here to here. So basically, what we can see that, okay, we need to we need to, okay, we need to find S7. Okay, we need to find S7, and then we need to find S1. And then S7 must be deducted with S1. Only then we can find the addition for T2 until 3 until the 7th term. Right? So basically, if you want to find from 2 from the 2nd until the 7th, so so here we said that we need to deduct the term before the second one, which is T1 lah. In this case is T1. Can you understand? Can you get it? So let's say if S8 minus S6, what does it mean? It means that T7 plus T8. You can see this is 7 and this is 6. Okay, the relation. Okay, the term that is deducted must be less than here. This must be less than this one. Okay, understand? Okay, so let's look at B. Sn minus Sn minus 1 is equals to Tn. Okay, let's say we have, okay, let's say we have T1, T2, T3, blah, blah, blah. And then this is, let's say, Tn. So let's say n equals to 10, let's say. So this will be T10, this will be T9, right? So if this term is Tn, so this must be n minus 1, correct? Right? Okay, less one than the next one. Okay, so when we talk about Sn, we are talking about the addition from the first term until the last term. And then Sn minus 1 is the addition from the first term until the second last term. So this is Sn minus 1. So what left is the last term. So we have proven that when Sn minus Sn minus 1, we will have the last term. Okay, I hope you can understand, because this information is needed for our next example. Okay, next. Example 3. Okay, given an arithmetic progression -6, 1, 8, 15, blah, 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 find the sum from the 9th term to the 20th term. 9th term to the 20th term. So we said that, we need to find T9, T10, T11, blah, 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 plus blah, 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 until T20. So based on previous knowledge, we know that, we need to find S20 and then divide it with Sy. This is n. So the number here must be less than this one, less 1 from this one. So we know that, minus S8, right? From the previous slide, the knowledge. So we need to find S20 minus S8. Okay? So you need to understand that. Okay. Next, from the question, we know that, A is -6, D is 7. And then we also know that we need to find the sum of the terms. So Sn is equals to n over 2 times 2a plus n minus 1 times d. So we need to find S20. Substitute the value. So we have S20 is 1210 and we find S8. Just like this one. Okay, this concept. S8, so we have our S8 is 148. So what is the total sum from the 9th term to 20th term? So the total sum is 1062. Okay, easy, simple. Next. Example 4. The sum of the first n terms of an arithmetic progression is given by Sn equals to 1 over 8 times 32/9 minus 9 squared. Calculate the first term and the common difference. Okay, this question, you are given the sum of terms. Okay, but the formula is quite different from the basic one. Okay, it is stated that the Sn is 1 over 8 times 32n minus n squared. So, we need to find the first term. Okay, so of course, first term is actually equals to T1 and is also equals to S1, right? Right? Okay, so when we talk about S1, so we said that, oh, the n must be equals to 1. So, we just need to substitute the value of n with 1 from the formula given. So, we will have our S1 31 over 8. Or we can say that, oh, our first term, A is equals to 31 over 8. As simple as that. Okay. And then we need to find the common difference. Okay. So difference, D is what? Okay. D is actually T2 minus T1. However, we don't know any value for the term. Except the first term that we calculate before. Which is 31 over 8. So, you are given the sum of the first n terms in arithmetic progression formula. Okay, which is 1 over 8 times 32n minus n squared. How can you find the n term? Okay, you are given Sn. We want to find Tn. So, this is where this formula comes in handy. Tn is equals to Sn minus Sn minus 1. Sn minus the sum of term before it. Okay. So, we know that we need to find T2. So, of course, T2 is equals to S2 minus S1. So, you know that Sn is as given, 1 over 8 blah blah blah. So, you just substitute n with 2. And S1 we have calculated before, which is 31 over 8. So, just do the rest of the calculation. We will have 29 over 8 for the T2. However, the question asks for D, right? Okay, D. So, D is equals to T2 minus T1. Okay, D is equals to T2 minus T1. So, our T2, 29 over 8 minus 31 over 8. So, we will have D is actually negative 2 over 8. Or D is actually negative 1 over 4. So, this is your answer. Okay, this is your final answer. D is equal to negative 1 over 4. Okay, next. The sum of the first 4 terms of an arithmetic progression is 36. Okay, sum of the first 4 terms. Okay, so we said that S4 is equal to 36. And the sum of the next 10 terms. Next 10 terms. Okay, so if we have T1, T2, T3, T4, T5, 1, T6, T7, T8, T9, T10, T11, T12, T13. Okay, from 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have another one, T14. Because dia kata the next 10 terms. Okay, the next 10 terms. So this is our S4. And the sum, okay, the sum of the next 10 terms. So this is our, okay, so this part, okay, we know that the whole will be S14. So we want to find this one from the 5th term until the 14th term. Okay, so of course, we know that if we want to find this one, which start from term 5, so of course, this part should be actually S14 minus, okay, since it started with 5th, so it must be deducted with S4. Okay, S4. Okay, and then the question asks for the first term and the common difference. So let's look. Okay, we know that, okay, this is our sum of terms in arithmetic progression formula. So from the question, we know that S4 is equal to 36. So use this formula. So we have 2a plus 3d equals to 18. Okay, 2a plus 3d equals to 18, say 18, sorry. Okay, and then we find S14. Okay, because this one. Okay, we find S14. So S14, okay, you substitute the n with 14 and then minus S4 will be 370. Okay, because this is S14 minus S4 is the sum of the next 10 terms. Okay, the next 10 terms. Okay, so the after we substitute, you do the linear equation and then you end up with 2a plus 13d equals to 58. So the question asks for two values, a and d. So when we talk about finding two unknowns, how can we find two unknowns? Of course, the method will be simultaneous equation. What is the condition in order for us to use simultaneous equation? We need to have two equations, right? So what are these equations? This one, the first one from S4 equals to 36. The second one is from S14 minus S4 equals to 370. Okay, so we said that, oh, we need to solve by simultaneous equation. Okay, so next. Okay. Okay. So next. Okay. Okay, so our next step is to eliminate A by equation 2 and equation 1. You can also use substitution, but since in this case we have the same coefficient for A to A, so I just eliminate A. Okay, eliminate A. So we have these steps. Okay, when we will eliminate A, we have 10d equals to 40, in which we have the value of d is equals to 4. And then, how can we find value of A? Of course, we need to substitute the value of d in any of the equations, 1 or 2. So, we will have our A is equals to 3. Okay. Okay. I hope you can understand. Okay, simultaneous is something that you had known. Okay, you are very familiar with. Okay, you are very familiar with. Okay, so let's look at another question. Okay, let's look at solving problems involving arithmetic progressions. Okay, example 6. A swarm of bees started to make a new beehive. 2 hexagonal holes were made on the first day. Okay, 5 hexagonal holes were made on the second day, and 8 hexagonal holes were made on the third day, and followed on until the beehive is ready. Calculate A, the number of hexagonal holes on the 12th day. B, the minimum number of days if there are more than 1,000 hexagonal holes day. So you need to remember, they represent n. Okay, they represent n. Okay, let's look at A. So since our sequence is 2, 5, 8. Okay, this is the first day. Okay, 5 is the second day. 8 is the third day, and so on and so forth. Okay, so we can see that, oh, this is arithmetic progression, because when T2 minus T1, 5 minus 2, we have 3. And when T3 minus T2, 8 minus 5, we have 3. So the fixed value. Okay, so we have our common difference is 3. So since we are talking about the total number of hexagonal, okay, the first day, the number of hexagonal 2. The second day 5. The third day 8 hexagonal. So when we talk about the total, so we are talking about the sum of the terms in that arithmetic progression. Okay, so and here is 12. So we need to find S12. So at the end of day 12, we have 222 hexagonal holes. Okay. Okay, next. B, minimum number of days. So n equals to what? Okay, the minimum number of n is what? When we have 1,000 hexagonal holes. So this is our Tn. Okay. Okay. Allah, Tn lah. Sn. Because the cumulative. Okay. Cumulative. Okay, so total number of days is Sn, in which T1 plus T2 plus T3 plus until Tn. So if our Sn need to be more than, so it must be greater. So this is why here greater. So Sn must be greater than 1,000. So we use Sn formula. So substitute all the values. Our A is 2, our D is 3. And then we have quadratic equation here, which is 3n squared plus n minus 2,000, which is greater than 0. So of course, when quadratic, you solve the value of n, we have two values of n, which one is positive 25.65 and the other one is negative 25.99. Since n refers to days, we don't have days with negative values. That is why here we said ignore. So our answer is n must be greater than 25.65. Again, n refers to day. Days must be in integer, so it cannot be in decimal. So when n greater to 25.65, the closest value of integer for greater is 26. That is why the minimum number of days to make the hexagonal be more than 1,000 is 26 days. Okay, I hope you can understand. Okay, let's look at another example. Okay, Encik Suhaimi is a chicken breeder that has 1,500 chickens. He plans to sell 200 chickens each day. He gives food to all the chickens with expenses 50 cents per chicken in a day. Calculate the total expenses of the food spent by Mr. Suhaimi if he starts with 1,500 chicken until he is left with 300 chickens. Okay, so in solving this question, first you need to understand the problem. So what is the problem? We need to find the total expenses of the chicken food until the chicken is left only 300 chickens. Okay, and the second step, we need to plan our strategy. So form an arithmetic progression series with the first term A and common difference D until the last term is 300, because the question asks for until we have being left with only 300 chickens. So 300 chicken is the last term. Okay. So determine the number of days for Encik Suhaimi to be left with 300 chickens by using the formula Tn, the n term lah. Okay. So number of days by using the n term. And then determine the total expenses of food when there are 300 chickens left by using Sn. So total expenses by using sum of the n terms. Okay, sum of the first n terms. Okay, let's look at it. So the first thing, okay, we need to identify the series. So from 1,500, okay, and then he sells 200. So the second day left with 1,300. The third day left with 1,100 until the last term only 300 chickens left. Okay, so our first term is 1,500 and common difference is negative 200 because D is equal to 1,300 minus with 1,500. So our common difference is negative. Okay, so since we said that Tn is to find the number of days in which the last term is 300, so our Tn should be 300, and then we solve the equation. Okay, substitute the value of A and D, so we have n is equals to 7. So it means that in day 7, our chicken or Encik Suhaimi chicken, the number of chicken that Encik Hamid has in day 7 is 300 chickens. Okay, so n equals to 7. So the question asks to find the total expenses from day 1 until day 7. Okay, from day 1 until day 7. From day 1 until day 7. Okay, so that's why we need to use Sn, which is S7. So use all the formula and we know that our Sn is 6,300. 6,300. Okay, 6,300 ni is actually chickens lah. Number of chickens lah lebih kurang. Okay, number of how can I say that? The cumulative the first day we had 1,500 chickens. Okay, the total expenses 1,500 must multiply with the price. And then the second day we are left with 1,300. The third day we are left with 1,100. So the cumulative number of chickens from day 1 is day 7 is 6,300 chickens. Okay, 6,300 chickens. So since the price for the food is 50 cents per chicken in a day, so 6,300 times with 50 cents. So we have actually our total cost from day 1 to day 7 is 3,150 ringgit. This is some examples that I want you to try, okay, and discuss your answer with your teacher. So do these 2 questions, and this is for your homework. Okay, this is for your homework. And last but not least, before I end up my session, good mathematics is not about how many answers you know. It's about how you behave when you don't know. How you behave when you don't know. So, I wish you all the best and good luck. And I end up my session with Assalamualaikum warahmatullahi wabarakatuh. Peace be upon you. Thank you.